Hello, SL2. Today's topic is the chain rule. We're going to use the chain rule anytime we see composite functions and we need to differentiate. So remember what the composite function is. Our first topic is when you see this f of g of x. What that means is the g of x is inside of the f of x function. So a composite function is generally made up of two simpler functions, and we're going to use that knowledge to help us derive these functions. So just a quick example to help us remember how that worked. If our f of x is x to the fourth and our g of x equals x squared plus 3x, then if the question asked me to find the f of g of x, we would have to put this x squared plus 3x in place of this x, and it would all be to the fourth power. So just a reminder of what this composite function is. Our goal when we come to our chain rule is we're going to be looking for those two simpler functions to help us derive our function. Okay, so here's our notes for our chain rule, and we have the same function of f of x is x squared plus 3x all to the fourth power. So again, it can be made up of two simpler functions where we can have y could be equal to the u to the fourth and u is equal to x squared plus 3x. A lot of times you'll see us use u when we derive, but just remember it's this concept here, the same idea where we used x. So this would be our f of x, and this would be our g of x, and we saw that this g of x was inside of our original f of x function. So now we're doing the opposite. We're pulling apart this function so that we can derive it and make it an easier problem. Okay. So let's look at the first problem here where we have f of x equals the square root of 2 minus 3x. What part here looks complicated to you or looks like you want to either, some students will immediately want to solve for what the y is, others will want to look for the part they're going to set equal to u. So in this first example, I'm going to do it first, what is the y? And I see that this whole thing will be, the y will be equal to the square root of u, because I want to simplify this to make my life easier when I go to derive it. And then u, then we know if it's going to equal this f of x is going to equal this, I'll have to say that u is our 2 minus 3x. Okay. Here in our second problem, we have a rational expression. And in this problem, and each problem you might approach a little differently based on what you see. But I want to go ahead and set that up to be equal to u. So that'll make it easier to set up what my y is. So this x minus x squared, I want to make that simpler. So I'm going to say that's my u. So if that's my u, my y would be equal to 1 over u. Okay. So this is one of the first things that we have to realize when we're using the chain rule. We want to make sure we see what are the two simpler functions inside. Then it's going to help us use our chain rule. So our chain rule states if y is equal to f of u, where u equals u of x, then the derivative of y respect of x is equal to the derivative of y respect to u times du over dx. And you can see how that's the case. If we were saying what dy over dx, here we can see if we cancel those du's, that dy dx would equal this side of dy dx. Alright, let's try to derive these two problems here. Let's start with number 1 and find our derivative. Remember, this is a notation as well for derivative, or f prime of x. And I have my square root of u. I'm going to go ahead and change that to u to the 1/2. Just like when I was using the power rule. It makes it easier to use that power rule. So then when I try to find my derivative of y respect to x, which is our f prime of x, then I first want to find the derivative of y respect to u. So first I will derive this. So I only have the u to the 1/2. I'm going to use that power rule, and we'll take this exponent, multiply by the coefficient. So we have 1/2 u, and then we're going to subtract 1 from 1/2. So that will make it minus 1/2. Okay. But we're not done yet. Remember, we used substitution here to help us make this simpler. So now we have to take the derivative of u with respect to x. So let's take a look at u. Let's derive 2 minus 3x. So 2 would go as it would be 0, as a derivative of a constant is 0. And then the derivative of minus 3x would simplify to minus 3. So this is multiplication here. Our derivative of y with respect to u times derivative of u with respect to x. Our last step will be substituting back in for u, so now that the whole item will be with respect to x. And at this point, when we would combine our negative 3 and our 1/2, multiply those, plug in our u, so here our u we said is 2 minus 3x, and we would also worry about the negative fractions here. So let's go ahead and multiply 1/2 times negative 3, and we'll move down our 2 minus 3x to the negative 1/2. Okay, so this is the derivative of our number 1 function here, the square root of 2 minus x. Okay, that made that ugly. I'll go ahead and fix that. Okay. Go ahead and try this second one on your own for a minute. Go ahead and pause the video and try this second one. Okay, let's see where you are on number 2 here. Here's our answer to number 1. So if I'm going to find the derivative of our number 2 function, 1 over the x minus x squared, then again I'm going to take the derivative of y with respect to u. So first I take the derivative, and how would I rewrite that? So that would be rewritten as u to the, that's right, negative 1 power. So when I take the derivative respect to u here, we can use the power rule, negative 1 u, and then subtract 1 from the exponent. Now we take the derivative of our u, so our derivative, and we multiply it by our dy du. So the derivative of x is 1, and the derivative of negative x squared would be negative 2x. Okay. Our next steps, and we can do it in two parts or at one time, would be we multiply this negative 1 times 1 minus 2x and substitute in the u. But also thinking about u to the negative 2, that's going to move the denominator. So let's go ahead and do that. I'm going to multiply negative 1 times my 1 and negative 1 times my negative 2x, which will be positive 2x. And then I'm going to substitute in what my u is, and we said it was x minus x squared. And that's all going to go on the denominator since it's a negative 2 power. So we move it down for the negative exponent, and then this will now be squared. Okay, so we've done two problems so far using the chain rule. You will also hear the chain rule called as the outside-inside rule or the inside-outside rule, and let's just think of it in a little different way for a minute. So if we think about it in this terms, and we go back to our first problem, which we found what u was and our y, we can solve it using the same method. So let's first solve it that way, and then let me show you another way to think of it. So remember we said that this is our function. Here is our u. We're trying to make this more simple. And our y would be u to the 4th. Okay. So when we derive it using this formula, we will take the derivative with respect to u. So the derivative with respect to x would be equal to the derivative of y with respect to u. So first here we have u to the 4th, and we'll have, so that will, to derive that would be 4u to the 3rd power. And then we take the derivative of u with respect to x. So our derivative here would be 2x plus 3. And then we go ahead and multiply our 4 times our 2x plus 3 and plug back in what our u is. So we'd have 8x plus 12 times our x squared plus 3x to the 3rd power. And you'll need to know both methods, this new one that I'm showing you, plus this u substitution. This inside-outside rule a lot of people have used is you think of two separate parts. The same thing what we're doing here, and you must take the derivative first of the outside. So if you think of this just like we did, set that as u, take the derivative and using the power rule, so it would be 4. Here, when you're using this inside-outside, which is another name for the chain rule, you leave this all alone. You subtract 1 here. Then you must remember to take the derivative of the inside here. And you can see this is the same, we're going to get the same answer here. So our last step is just multiplying the 4 times the 2x plus 3. So depending on the problem, I might use this quicker method, or if it's very complicated or even a little bit tricky, I'll use this u substitution. So as we work through these, you'll make a choice of that as well. Okay, the next part of the video, I will prove the chain rule, so stand by for that.